especially for Sec 4 students, when you are transiting from redox reactions and metals towards this chapter, you will realize that there are some difficulties, okay, when you move on to this chapter, as it is a little bit new to you. So through this video, I will hope to summarize for you the exothermic and endothermic reactions, as well as how we remember each of the reactions itself. All right, so first off, let's look at exothermic reactions. Okay, exothermic reactions, as the name suggests, is when heat is going to exit the reaction. Okay, heat is going to exit the reaction. Now, this is very important. Okay, when you note the word exothermic reaction, okay, heat is exiting the reaction. That's how you remember. Okay, now what does heat exiting the reaction mean? It means that energy, okay, is being released, right? So energy is being released. This is the key concept over here. Now, if I were to use an energy level diagram to illustrate this idea, it will look something like this. Okay, so first off, we have the reactants. Okay, so for reactants, let me just give you an arbitrary level. The reactants are over here. Now, this is energy, all right? For products, what happens is that you will realize that since energy is being released, the energy level definitely must go down. This means that products level must be lower than the reactants level. And you will realize that over here, this, okay, which is your energy change, also known as your enthalpy changes, would be a negative value. All right. So to summarize again, because heat energy is given out, that is the reason why the reactants have a higher energy level compared to the products. And this means that when heat energy is being released, what happens is that the surrounding temperature is going to increase. Okay, so this concept over here have already been summarized for you in the drawing above. Now you notice that the delta H value, okay, which is your energy change, is negative. And we can also say that the heat that is given out in the bond forming process, okay, is greater than the heat absorbed in the bond breaking process. And that is the reason why, okay, the delta H value will be negative. Now, after a heat source is being applied, the reaction can continue on its own, because we know that for a exothermic reaction, it just needs to cross the activation energy barrier, and after that, the reaction can continue by itself. For endothermic reactions, on the other hand, it is a little bit different. So for endothermic reactions, heat is going to enter the reaction. Okay, so endothermic stands for enter, enters the reaction. Now, what does heat enter means? This means that energy is being absorbed by the reaction. Energy is being absorbed by the reaction. All right. And since heat energy is absorbed, what happens is that the surrounding temperature will lose energy towards the reaction itself, and this causes a decrease in the surrounding energy temperature. Okay. So you can see over here that the energy of product is greater than the energy of reactants. Let's illustrate this on the energy level diagram again. So you notice that since I need to absorb energy, originally my reactant is at a low energy level. Now it has been elevated to a high energy level. This is my products. Okay. So you notice that the delta H value, this is the changes, will be positive. Okay. So more than 0. All right. And you can also realize that, okay, the heat given out in bond making is less than the heat absorbed in the bond breaking process. And the reactions cannot continue on its own because it has a requirement for the heat to be constantly supplied. Okay, I need to keep constantly supplying the heat to the reaction itself for the reaction to actually proceed. All right. Now let's look at the energy profile diagram over here to understand a little bit deeper. So when we look at the energy profile diagram, you will realize that for all reactions, the activation energy will be positive, okay? For any reaction in this world, you are required to overcome what we call an activation energy barrier before the reaction can start. Okay, so reactants, bonds in the reactants must be broken by absorbing energy. What happens after that? Once it reaches this point, okay, it's going to lose energy to form the products. And this over here is an exothermic reaction since delta H value is negative. On the other hand, on the right hand side, you can see that the activation energy is also positive. So you realize that activation energy, which is also denoted as EA, is always strictly greater than zero. For any reaction, no matter exothermic or endothermic, it will always be greater than zero. And for this kind of reactions, the activation energy, okay, will be greater than the delta H values as well. Okay, so reactants and products. So this is how, okay, you draw an energy profile diagram. Okay, so you should change this to energy profile diagram. I hope this video has helped you with your understanding of energy changes. If you like more of such videos, okay, you can react to this video or you can leave a comment.